So when you look at the example here, both sides share the electrons equally. So if A and B have what's called electronegativity, they're the same, then there's no charge on the molecule. If there's an unequal sharing of the electrons, then what happens is the B has more of the electrons than A, and that's what causes this to happen. And if it's a huge difference like that, then there's a huge electronegativity. Okay? This talks about this side being negative and then this side being positive. So that's kind of good that you can see that. It's always going to line up negative to positive, positive to negative. Okay? Then also we have our water. And you can see the charges here. These are positive, and this is negative. This is where the oxygen would be. So if this was water, you can go ahead and see that the negative is going to line up toward the positive and the opposite like that. So, now this is what pulls ions apart. Is this side is attracted to sodium, or the negative part, and then this side's attracted to the positive part. So we'll go to our examples. Before we get to that, KCl dissolved, right? Yesterday or 2 days ago? Okay. Because these positive negatives are being pulled off by water's opposite charges. Naphthalene doesn't show any charges. So the reason why is because C and H, they kind of basically share the electrons equally. They like to share. Okay? And so they share equally. And so that creates a situation where there's no difference in their charges. That's just the easy way to explain that. On this one, there is a big difference in what we call a sharing that takes place between these two, and this side's going to be negative. Plus these have extra pairs of electrons, so water's attracted to these electrons. So that's why that one dissolved. This one did dissolve. Do you guys remember why? So calcium carbonate didn't dissolve. Why?
Because it has two.
Yeah, so the +2 and the -2, what does that tell you about their attraction? Yeah, they're a lot stronger. Be a lot stronger, less likely to pull them apart. That doesn't mean everything's a +2 and a -2 is not going to dissolve. That's not what that's saying, but I think if you look at enough examples, there's a high percentage that would be that case. Okay? If you look at iodine, none of that there. None of that's breaking apart. Well, I'm sorry. Water can't come in and pull that apart because there's nothing that attracts it to pull apart. Now it did dissolve in hexane, right? So those ones that didn't dissolve in water, other than calcium carbonate, dissolved in hexane because they're alike. It's kind of like cliques at school. There's certain groups of students that have similar interests, and they kind of mix. Okay, but a lot of times certain groups don't mix because their interests do not, allow them to mix. They just don't do it. Okay? So, these are like that. Iodine will mix with something similar to it, and hexane similar to it. That's why it'll mix. Okay, so we get to our question. Let's see how many of you guys get right. Okay, so you're just making predictions. So, up to yesterday, you have no understanding, or very little understanding, of what's going on when it comes to something dissolving. So, I'm just going to go through these and we can explain them later. Number one, if you made a prediction, it dissolves. Okay, it's okay. We'll just keep track. So it dissolves. Number 2 did not dissolve. Okay. Number 3 dissolves. Number 4 does not dissolve. Number 5 does not dissolve. And number 6 does not dissolve. You got how many wrong? That's good.
I got
I
missed
don't
two.
think you have to tell, 'cause I don't know.
You got them all wrong?
Yeah, I don't understand how you're supposed to tell.
Okay.
I don't get it.
All right.
Which answer you go?
So, go back to our examples. Okay, just really super quick. Go back to our examples, the ones that dissolve. Yep. If you didn't get it right, then that's not good. So, go back to our examples.
Hey, that's not nice to tell people that.
Hey guys, I'm recording this, so.
No fighting in my act.
Well, she's being mean.
You should be quiet.
She's being mean. Hey, that's my phone. That's all.
Dissolved in the lab.
Yeah.
This one dissolved.
Yes.
Okay? This one did not dissolve. Dissolved. Dissolved. Did not dissolve. Did not dissolve. Okay? So go back to our examples. Why does this one dissolve? I want you to look at this.
These are not bonded very well.
Well, I want you to look at this section right here. It has those electrons there, like in the other example that we had. See these electrons there and how it dissolved, and then we look at our example here. Both of them dissolve because this is what the H's are attracted to, and we'll pull them apart. Okay, so that's why that one would dissolve. This one doesn't dissolve. Is this like one that we had in our examples?
Probably. Good on you, everyone liked it.
Like that one.
Yes.
C and H's, and we don't have any electrons that are going to be paired with it. Okay? This one dissolves because it's ionic. Alright? Now, some of you could have got away and said it wouldn't dissolve, and what your answer why it wouldn't dissolve is because what? So if you said it didn't dissolve, why would you say it didn't dissolve compared to the 6 that we did? It should have been okay to have that answer if you logically would explain why. Yep.
Because it has aluminum.
No.
You said metals don't dissolve.
No, metals by themselves don't dissolve.
Wow.
Could it be because it doesn't have any hydrogen or oxygen in it in all the other streams?
Now this is ionic, and we say most ionic substances dissolve.
Yeah.
Okay? But the reason why you say this one might not dissolve because it has a +3. Big charges, a lot of times, may not dissolve. So, the difference between those is a little bit bigger. How about 4? Why? Big charges. So number 4, +4 -2, it's kind of like the calcium carbonate that was a +2 -2. Cl2, that's this Cl's put together like this. There's no difference in their electronegativity. It's like that one example I just did for you. Okay? Which would be right. the example right here, there would be no difference in their charges, so there's no difference. More neutral, and so it's just neutral, and it's not going to be attracted by water. Okay? All right, and then the last one is the same as the COs. It's just kind of like this one. There's no electrons in that shown, so that's why that one didn't result. Okay? They were just predictions. Okay. I'm going to give you a sheet out. We're going to go through some things on concentrations. Okay?
So we're gonna turn like this in?
No, we're not going to turn that in. Quick. We're not going to take too much time. Yes, ma'am. Do you have a statement? No? Okay. So, this one I want you guys to figure out on your own. We'll see if you get it right.
Do what?
Okay, here's the equation, percent mass. What is it? It's the mass of the solute in lesser quantity divided by the mass of the solution times 100. Okay, this is not a mass, but you can find the mass using this value, the density. So go ahead, I'm going to give you a minute to do that calculation. Find the percent sugar in that mixture. I want to know. So biologists, all the other chemistry, all the other sciences, really, they look at percentages. That's their main focus, is percentages. So if you're in a life science class or do things with life science and you got solutions that you're working with, mixtures, they'll say, hey, this mixture is made up of this percentage. And it tells you the percent of the solute that makes up the total percentage of the solution. Okay? Chemistry, we don't use percents. I don't like percents because all it tells me is mass to the mass of the total. And I'm usually looking at things, I'm looking at reactions I'm going to be doing with it. Okay? Alright. So, let's see what answers we got. So, you guys throw out some answers.
That's what I got.
What'd you get?
12.75.
12.8%?
Yep.
How do you do that?
Anything else?
I don't even know how.
Any other answers different than 12.8?
That looks right. That's it.
Did you divide by the total? What's the total? What's the total mass of the stuff? If we put it on a scale, what would be the total mass of the stuff?
Would it be 225?
225.5. Did you use 225.5? Okay, so we want to take the mass of the sugar, what we're trying to find a percent of, and we're going to divide by the total mass. The total mass is 225. Now that would get your percent. I think it's going to lower it, right?
11.3.
Okay, so 11.3 is your answer. So remember, when you guys do these, always add your two weights together. You're probably just going to have two weights. It doesn't mean all the time you got two weights. But for the most part, every time we do a problem in here, we're going to have two weights. Or a volume that we can find a weight. Everybody knows why this is 200 grams, right? Because you took 200 milliliters and you said for every 1 milliliter of water, I have 1 gram. It's the same, 200 grams. Most of you didn't do that. But you may have to do that when it's not exactly 1. So that you can figure it out. Like the next one. So figure out the next one. What's the percent of, I think it's ethanol, right? Find the percent sugar when it's mixed with ethanol. So then go ahead and figure that one out. And the density of alcohol is less than water, and that's why when we did that experiment, we took the ice cube and we put it in the liquid, it sank. It's because ethanol has a density less than water, and then less than the ice cube as well. So see what you get for that one, and then we'll see what you got for the answers. Remember, always has to be divided by the total. Whatever you want to find a percent of, your percent has to be of the total. Like if they find a percent, they take calipers and they find a percent of fat, for example. Okay? That's what they're going to do. Mariah? You're going to have to pay attention. That means you're going to have to look up here.
To get the 225, you just add the 2, right?
Yeah, so what you always want to do on every single one of these is add your two weights together.
Okay.
You always add your two weights together. So you guys definitely did this one right. I know you did. You guys are fast learners. So you guys took 100 milliliters, and then you found the actual mass of ethanol, and you took it times 0.79, so you got 79 grams of ethanol. And then you added 79 to 2.5, so then it would be 2.5 grams of sugar, and you would divide by the total, which was 81.5, right? Times 100. What'd you get for percent? 3 point, is it 3.1?
Yeah.
Okay, 3.1. Okay, good. You are learning. All right? So look, again, I'm going to say it again. Most people will do this problem, they'll do it wrong because they'll do what? 2.5 divided by 79. 79 is not the total. Anytime we find a percentage, if I find my batting average, and I have like 8 hits, and and I came up 20 times, it'd be 8 divided by 20 times, in percentage, that would be times 1,000 to get the batting average, something like that. They're a little different. Okay, this is volume, but it's not any different. Now, do you guys have a volume one that's not this one? Do you have a volume one that says, what is the volume of 40 milliliters of ethanol and 250 milliliters? Okay, use the same concept on that one. Okay? Go ahead and use the same concept on that one. And see what you get. It's just volume, though, the difference. So you're just using whatever the volume is. It's percent by volume. This has to do with liquids.
That ain't right.
Okay, you guys got an answer out for that one. What'd you get?
13.8.
13 point what? 13.8. Everybody agree with that?
Yeah.
Okay. So you guys took 40 divided by 290, right? And that's what? 13.8%. And label it. 13.8% ethanol, right? Okay. Okay, do your next one real quick. And then we'll be done with percent by volume. So go ahead and do next one, find the percent propanol. These are all that easy. Okay, these are all that easy. See, biology is easy. when it comes to this stuff.
I got it.
Is it 9%?
9.1.
9.1%. Good. So 2.0 liters divided by 22 liters times 100. We're moving on now.
Is that propanol or butane?
That would be. All right. So the first one, you guys took the grams of chlorine, right? You put 0.0075, and you divided it by the. Did you divide by 50, or did you do it like this? 0.0075 divided by 50.0075. Which way did you do it?
I did this.
You did the second way? Did anybody do the first way? Okay, let's compare the answers. So, and then you multiply by, of course, 1,000,000 on both of them, right? Okay, so let's see if there's any difference between them. So what'd you get, if you did the left side, what'd you get for an answer? 150. Was it exactly 150?
Yeah.
Parts per million. If you did it this way, you got an answer of what? 1?
It was it was 150 if we rounded it up.
Okay, this tell me exactly how many went.
149.97.
Okay.
It's more accurate.
That side is more accurate. When you do these, you do not have to add in the 0.0075. Okay. Now, if this is bigger, like if this is 0.75 grams, do you think the answer is going to change very much if we add it in? It will. Okay? So then it would be 0.75 divided by 50.75. And it would probably be more difference between them. But since we do it parts per million, I think you can get away with. So go ahead and do the next one and see what you get for that.
So you don't want us to add it in?
Well,
Does it matter which one we use?
if this is real, here's the deal. If this is really small compared to what you're dissolving in, then you can just do one over the other. If this is a little bit bigger,
Then add it.
then you probably should add them. So you just have to use your. So on this one, it's what is it? It's what did you get for this one? 70, 60?
Like 65.
What'd you get?
I got 65.995
So 66 parts per million.
cents.
Everybody get that?
Bless you.
Okay, good. Now, let me ask you a question. If we're saying something has 66 parts per million and it's like a sodium ion, and you drink it, you think it'd be harmful to you? When I say sodium ion, it's like sodium chloride. Like a little bit of salt, just like 2 or 3 speckles of salt dissolved in water. You think that, will you taste it? No. Let's say that there was 66 parts per million of lead.
That's terrible.
That would be terrible?
That'd be detrimental.
Yeah, it would be. It really would be.
Yeah, you would die from that.
You know, I don't know.
Well, if you kept drinking it.
But the thing is, what happens is lead. Your body doesn't get rid of lead. So, there was this individual when I first started teaching. This is kind of interesting, I think. We had off to the right side. I'm going to write down these weights, and then you guys convert all these to moles. Okay. The first one's really easy. If you can't do the first one, you might as well get out of chemistry. Okay? Second one's a little bit tougher, but not too much tougher. I don't know why I did sodium twice, but I did.
Sometimes it's okay to put a little more sodium on.
Okay? Third one It'll make it easier for you guys, but I didn't need to make it easier for you. Try to get this done before you leave. I think you can. So, all I want you to do is figure the moles of each one of these, and you're done. Find the moles of each one of those, and then you're done. And then tomorrow we'll talk about what is most important to chemists. But biologists, they don't care about moles.
Are we going over this?
I don't know what their problems are. What?
Are we gonna go over these tomorrow?
You bet.